In example 8, we are going to verify trigonometric identities. So one of the things we can do with trigonometric identities is use them to verify other trigonometric identities. Now, in this process, we will choose one side of the equation, usually the more complicated side, and we will show step by step how we can transform one side of the equation into the other. Unlike when you solve an equation, you cannot work with both sides at once. So we are going to only work with one side. So in example 8a, we're asked to verify the identity cosecant theta times tangent theta is equal to secant theta. So the more complicated side is the left side of the equation. So we are going to try to transform cosecant theta, tangent theta into secant theta. So one strategy that you can use is you can try to write, so this is a strategy that you can often use, is write all the trig functions in terms of sine and cosine. And the goal then is once we do that, then things can cancel out and maybe we can transform one side of the equation into the other. So for this trig identity, that's a strategy that we can use. So we can look at cosecant theta. If we want to write that in terms of sine or cosine, we can recognize the reciprocal identity and we can write cosecant theta as 1 over sine theta. And then tangent theta, we can use the quotient identity and rewrite that as sine theta over cosine theta. Once we make those substitutions, now we can use simplification with algebra, and we can cancel out the sine theta in the numerator of the second fraction with the sine theta in the denominator of the first fraction. And now that's going to leave us with 1 over cosine theta. And then by the reciprocal identity, 1 over cosine theta is secant theta. And then we'll put a check mark at the end because we have verified it. When verifying identities, you don't have to put the names of the properties, but you do have to show every step in the algebra involved in those simplifications. In example 8b, we have another trig identity that we're asked to verify. And here we have the quantity 1 plus sine theta times the quantity 1 minus sine theta is equal to cosine squared theta. So once again, we're going to start with the more complicated side, which is the left side. And when you're verifying trig identities, you'll use a lot of the simplification or techniques that we learned earlier with algebra. So if we have 1 plus sine theta times 1 minus sine theta, we can expand this, or we can FOIL this. And you'll notice that this is actually a difference of squares. So we can FOIL this out or recognize the difference of squares pattern as our first step. So if we expand that, we're going to get 1 plus sine theta times 1 minus sine theta is 1 minus sine squared theta. And then by the Pythagorean identity, so I'm going to just kind of put this on the side. This isn't really part of the verification, but I'm just going to put a little note here. So we know there's a Pythagorean identity that has to do with sine squared theta and cosine squared theta, and that is that sine squared theta plus cosine squared theta equals 1. If we rewrite this, subtracting sine squared theta from both sides, we'll get 1 minus sine squared theta equals cosine squared theta. So this isn't part of the verification, it's just our thinking off to the side. But once we do that work, we can now substitute in cosine squared theta instead of 1 minus sine squared theta. So we have cosine squared theta equals cosine squared theta. So we've verified this identity with just 2 steps.